Hello everyone, today I'm going to show you how to fit a demand power curve. Let me tell you where we're getting the initial input for the problem. The problem is, or the question is, here it is, estimating linear, we've done that, estimating power. So here, we are assuming that a product is currently selling for $100. So this is the price of the product, the current price. So we have a price, and this price is $100. This is the first thing. Remember what we said in class. Demand, we're going to always express it in terms of formulas. And demand equals to 500 units. Assume also that the product's price elasticity for demand is known to be equal to. You can fit the power demand curve. So fit the power demand curve. All right. So let's take a look. Here, you have an elasticity of 2, and you have here, as you can see, you have the demand. Now you might make the mistake and put the demand as 500, and then you're saying to yourself, any demand curve should look something like how Nora said, the Q, the demand, the quantity, is equal to A, which is a parameter, P, the price, to the power of some elasticity. Correct? Yes, that's right. So this demand over here, we're going to delete this, and instead we're going to put so this is step number 1. Step number 1, express demand as a function. So here we're going to go equals A. Oh, I didn't put any place for A. So now is the time to put A here and see what it is. Now I want to show you something quite easier than last time. I showed you that we can name this cell, which here in the cell name box or name box space, you can call it as an A, right? So here, oh, it didn't because we didn't hit enter. So this is A. So now I'm going to show you also another way, which is something that we are going to use it in the future, but maybe for now I should go easy. I should go easy. Okay. So this, I'm going to call it elasticity. I don't want to type it again, so I'm going to just copy that and then on the name box and hit enter. If you don't hit enter and go back again, oh yes. If you don't hit enter, you won't be able to do it successfully. This is 2, we're going to call it price. And guess what? This is 2, we're going to call it demand. But demand, we are not going to express demand in terms of numbers. Rather, we are going to use it as here's demand, here's price, elasticity, and here's A. And you should know this. This you should remember and know that this is the power, the general form of a power demand curve. So this is Q, quantity is equal to A, this A, times price to the power of 2. That will cause a mistake. Elasticity here is 2, but here it's to the power of minus 2. So it is minus the elasticity. So this is express demand as a function. All right. Then we are going to find number 2. Use use what data? use data and what if to find A. All right, so now we're gonna find the data and we're gonna find what if. Goal seek. So you're gonna use what if goal seek. So use data, what if, goal seek, and then set cell to value by changing. In fact, what is the role of A, so that you can really understand what's going on? What was the name of that online plotting tool? It was a very popular one. Desmos. Yes, a graph calculator. Let's see. Maybe I do have something in there. Let's see if I can log in there. Yes. Let's see if I have something here. This is something different. Okay. Do I have the power curve somewhere here? Okay, so let me do it now, and let's call this the power demand curve. Okay, over here. So we're gonna have y, which is a q, equal a x to the power of minus b. Now we are going to use a slider. Now this doesn't look to you like right, but it is right. We just don't have any quantities or prices in the negative, so we are not concerned with the negative side. This is why we're going to focus here on this side, and this is what a demand curve will look like. It almost approaches zero, as you can see here. It almost approaches zero on the very tails, and we're concerned with the positive side here with positive prices and positive quantities. All right, let's see. This is elasticity, and this is elasticity when equal to 1, but usually elasticity here is I put it in the minus, yeah. So elasticity will always not be equal to here in the negative, because then negative times negative is positive, so it's always going to be here looking like that. Okay, good. So as you can see, this is what elasticity does. Elasticity, as I told you, will show you how much we are bending this, how much we're bending this, so that it will make it almost vertical, or in a sense here more relaxed, yeah. So our elasticity is -2. So here the configuration of the elasticity. Now what the A does, A is going to be always in positive, it's not going to be negative, okay, because it flips it down. Let's take a look. What does A does? Do you see? The bending stays the same, but it is lifted up a little bit. It is a little bit farther away from the origin. So the distance almost from the origin is what we find here. So this is A is 2, but A could be something even more. A could be something even less, and so on. So this is quite interesting. So this means we really need A, because this is what A does. So it is interesting to see that this is what A does, but here this is what how close to the how close you are going to meet the axes here. All right, so right now let's take a look. This is A. All right, this is A, elasticity, price, demand. All right, demand in fact was given to be 500 when price is equal to 100. So you don't have to memorize that we are going to express demand in terms of a function, because this 500 changes with price. When you increase the price, decrease the price, this 500 is not is a constant, but here this 2 is constant, right? Now you're going to say, why don't I don't put the price then? Because we don't usually express any formula in terms of price is equal. We usually put a formula of demand, A times, this is where A, we could find A because it is involved in a demand kind of equation, okay? Excuse me. All right, so now let's use data, and let's use what if, and let's use goal seek. And now definitely we are changing cell A. So by changing cell A, so set cell to value. So we're going to set this cell demand to which value? To 500. Hit OK. In class, I showed you, unfortunately, we were running out of time. I showed you that this, if you forget the negative, you will see that this is going to be in the probably decimals rather than in the 500s, okay? But this is not right, isn't it? Because I took the, by mistake, this 500. So price is 100. This is why you will see here, for example, here, this maybe we are going to put it x, we're going to put it 100 to the power of, yeah, because if we put it 100, then it won't plot it because it's no longer a variable, right, you guys? So we're going to have to put this as 5 million. And this is -2. And now where is the curve? It is somewhere here. And it's all right. It just looks different because for us, we want to see that 100 somewhere here, maybe, as you can see, hitting the demand curve around 500. Do you see that? So this is what we're trying to do here. We want to see that this 100 is actually hitting the demand curve exactly where it should here in the 500. Do you see that? And you want to plot this demand curve. Of course, you can plot it using the Desmos. It's easy, isn't it? You just put y for q and equal 5 million x to the power of -2. I agree with you. It's way much easier. But I want to show you that here, this is just you have a point here, and this point is 100 almost to 500. But you need to get other points. For example, you want to know how this curve looks like, yeah, and try to plot it with Excel. The way we do this is we have two, we say Okay, so now we are going to plot here. Let's put here price, and let's put here demand, and here let's say this is 0.1, 2, 3, 4 above, and this is where we are right now. We are at 100, and this 1, 2, 3, 4 below. So let's get started here. We're gonna have 1, 2, 3, 4, then 100, 1, 2, 3, 4. Perfect. And now let's do this, and let's have this gonna be 90, but if you want to do it in a very stepwise decrement, this is gonna be 10 maybe decrements. Let's do it this way, and then this is gonna be 100 plus 10, which is be 110, then here, here, and here. And then we have demand is equal to A. You can type it as you wish, as is, or because now you use the cell name, it's easy. You don't have to add the dollar sign. A times this price point to the power of minus elasticity. So now you're getting the demand when the price is 60. Some of you are gonna say, what about the decimals? How come we are having decimals in there? And this is the point that was given to us originally, right? So by knowing only one point and knowing the behavior of our curve, be able now definitely to plot this. So you can put insert, we can plot it like this. This is, as you can see, the different prices, and this is the different demands. So let's put a quick layout. Which one shall we use? Let's see. No. Oh, go in. I need to add then add the trend line, and it is power. And why don't you display the equation just for fun? And as you can see, here is 5E means E is a replacement of all these zeros. So do you see 6 zeros? This is why we have the E. And here is 0, 6. So it is A plus some B X, actually A times the price, which is X to the power of minus 2. But here we have, probably I forgot the B in here. There should be some B here, isn't it? I think so. But as you can see here, based on here we were talking about the elasticity. Let me just take a look. We put here B to be the elasticity, but we don't have any other. Okay, so over here there shouldn't be So ne, sokka, I forgot. This is, I'm sorry, I'm really tired tonight. This is e plus 6 means it is 6 zeros. So this 5e plus 6 that you see here, I'm sorry, Gominne, this 5 is this 5. I'm sorry, I'm tired. This 5 is this 5. And now I see clearly. E plus 06 means, as I said, there's 6 zeros. 1, 2, 3, because it's in million. So this is what the 5e plus 6 means. Then x to the power of minus 2. So this is the demand curve, and this plus 6 is with the e, and it means how many zeros. All right, so let me just take a look at the format here, or the format here. And with the format, student might ask me, how can I add that. Okay, so let's add a quick layout. At least let me have the, for example, some titles of the x and the y. So you can have that easily by adding the x and the y's this way. I just add here. So this way. So as you can see, I don't know what this is now, and this is just a point. I don't need this. You can also keep it, but we don't need it. And here you can add a trend line, and this trend line will be power, and that's it. Of course, you can add the function if you feel that there is a possibility that this will confuse you. I hope you don't know with my explanation. This is altogether is one thing. It means 5 million. Okay, so here, this is the demand, all right, and this is the power demand curve. I think it's self-explanatory. It's going to be price, and this is going to be the demand. It's not quantity here, and the demand is in fact the demand curve. And this is the power demand curve. So that is the power demand curve over here, and here is the expression of the equation. Here is the expression of the equation, as you can see here, and it is we've been able to actually plot a little part of it due to the fact that we know how much was the demand for a certain price. Yes, given that we also know that the behavior is bounce. Okay, auto. But the major units 50 and 10. Yeah, but I want to show it though. So maybe every 10 I want to show. Does it work this way? This is for this, okay. And how about axis options? Minimum, pounds, measure. Okay. You can play around with this, or you can just extend it. So here you can see easier the points, which point here corresponds to which quantity. And this is how we plot the power demand curve. So don't get a little bit confused with the fact that the Excel is going to give you the power demand curve this way. Even without the Excel, you are going to be able to plot this by saying that the demand, or Q, is equal to 5 million, 1, 2, 3, 1, 2, 3, times the price to the power of minus 2. And that would be your demand curve. You can write it yourself if this is confusing, but you should verify what you got here with what you got here. And the E plus 0.6 is basically 6 zeros. Thank you so much.